Question 7. List two properties of cathode rays. B. Explain how the intensity and energy of cathode rays may be increased. A. Properties of cathode rays are 1. Are negatively charged. 2. Travel in sight line in field-free space. 3. Are deflected by electric/magnetic field. 4. Possesses kinetic energy. 5. Possesses momentum. B. I. The intensity of cathode rays may be increased by raising the temperature of the cathode / increasing the current through the heater. II. The energy of cathode rays may be increased by raising the potential difference between the anode and the cathode / anode potential. Question 8. Give 3 observations in support of de Broglie's. Question 8. Give 3 observations in support of de Broglie's assumption that moving particles behave like waves. Particles, wave behavior. Example: electrons show diffraction. Electrons show refraction. Electrons show reflection. Electrons show interference. Moving electrons exhibit wavelength frequency. Determination of molecular velocities. Question 9. Given a retort stand and clamp, a taut spin, a simple pendulum and pencil, describe how you would use this apparatus to determine the center of gravity of an irregular shaped piece. Describe how you would use this apparatus to determine the center of gravity of an irregular shaped piece of cardboard of a moderate size. Answer. A. Procedure. Make at least 3 well-shaped pinholes round the edge of the cardboard. Clamp the pin horizontally and suspend the cardboard on it through one of the pinholes such that the cardboard can swing freely. Hang the simple pendulum on the same pin and let it swing. Procedure. Make at least 3 well-spaced pinholes round the edge of the cardboard. Clamp the pin horizontally and suspend the cardboard on it through one of the pinholes such that the cardboard can swing freely. Hang the simple pendulum on the same pin and let the string be very close to the cardboard. When the whole system is at rest or in equilibrium, trace the plumb line on the cardboard. Repeat the procedure for each of the 2 other pinholes. Repeat the procedure for each of the 2 other pinholes. Conclusion. The point at which the 3 traced lines intersect is the center of gravity of the cardboard. Precautions. Repeat procedure. Pin rigidly and firmly held by retort stamp and clamp. Allow the simple pendulum to rest before tracing the shadow of the plumbing on the cardboard. The string to be close to the cardboard. B. Using a suitable diagram, explain how the following can be obtained from a velocity time graph. I. Acceleration. II. Total distance covered. Answer. See the diagram on the screen. B. Diagram. Both axes should be labeled correctly. Any correct shape of graph showing acceleration segments. Acceleration equals gradient of AB. Total distance covered equals area under the graph. C. A body at rest is given an initial uniform acceleration of 6.0 meters per second squared for 20 seconds, after which The acceleration is reduced to 4.0 meters per second squared for the next 10 seconds. The body maintains the speed attained for 30 seconds. Draw the velocity time graph of the motion using the information given above. From the graph, calculate the maximum speed attained during the motion, total distance traveled during the first 30 seconds, average speed during the same time interval as in II above. Answer. You can see the diagram. At least one axis labeled correct shape of graph. Let V1 equal maximum velocity after 20 seconds, V2 maximum velocity after 30 seconds. Then V1 equals 6/20. Therefore, V1 equals 120 minutes. Therefore, V1 equals 120 meters per second. Also, V2 minus V1 equals 4/10. V2 minus V1 equals 40. V2 equals 120 plus 40. V2 equals 160 meters per second. Maximum speed equals V2 equals 160 meters per second. II. Total distance covered equals area of angle plus area of trapezium after first 30 seconds, which equals, in parentheses, half times 20 times 120 plus half into 120 plus 160 times 10 equals 1,200 plus 1,400 equals 2,600 meters. III. Average speed equals total distance over total time, which equals 2,600 over 30, which equals 86.67 meters per second.